Hi everyone, this is Sage. Today we're going to be working on experiment 5, our calculations for that. This one should be fairly easy. Once again, I will be giving you this template to assist you and to help you understand what's going on. So if you follow along with this, you should be pretty okay. Okay, so the first thing I want to point out here is anything in blue is stuff that you should already have uh, from your pre-labs that you turned in um, at the end of our experiment. As you can see, we recorded these molarities and these volumes. We also recorded our times and absorbances. You can adjust this around as needed, but it should match up pretty well and you shouldn't have to add anything in. So I have some sample data here. I am going to change it around a little bit. So it might be a little wonky, but it's okay. Just use your own data, of course, as usual. I'm going to fill that in and we'll meet back up once we have our tables filled in. All right, so some important, well, I filled out the table. Firstly, you'll see that I filled in all of these molarities and volumes. Your volumes should be in liters. And I filled in all of our absorbances. So everything in blue is currently filled in. If you want to not have to type this concentration out as a decimal, you can just use the scientific tab over here. That'll change your whatever data is in here to a scientific notation. As you can see, it did here. Yeah, so we'll move on from that. So what do we do now? There's some very easy things that you have to do here. For example, we need to get all of our absorbances and take the natural log of them. So here we just do ln of this cell here. And then we can stretch this formula down like I've showed you guys a few times by holding on this bottom right little square that was there, dragging it all the way down. And that'll take the natural log of every single cell. It'll look to its left and take the natural log of that. So for this one, now it's very similar. We just do equals 1 over this cell here. Great. And now we can do the same thing. Click on this little square, drag all the way down. Really quick, I did want to say, some people have come to me and they're using the online version of Excel. I would recommend, if you haven't already, downloading the desktop version of Excel. I'll note specific places where it's going to cause issues. You've probably already seen it in past experiments. If you've only been using the online version of Excel, just download the desktop version. Again, you get it for free. Email me if you don't know where to find it, but try and find it on your own first. Okay. Then we're going to do the same thing over here. We're going to take the natural log. Oh, I didn't do that right. Go, and then drag all the way down. Pretty easy, nothing crazy. This is just getting all of our stuff set up for the analysis we will do later. Oh, I went one cell too far, and I will just get rid of that. Cool. All right, now we have everything we need to make our graphs. Now this is where the desktop version of Excel is important because plotting in Excel online is just weird, and it might give you some weird stuff or weird errors, and you'll be able to follow along more closely if you just download it, the newest version of Excel. Then I can help you. Okay, so we're going to click on this graph one. So graph one is just going to be a plot of the absorbances with respect to time. So for me, I'm going to right click on this chart. I'm going to do select data. And then we don't need to name it or anything. It's fine. We can just select the X values. The X values will be time. And the Y values will be our absorbances. So I'm just dragging all of these and that will select it. And oh, wait, I forgot. I have to add a series. Hold on. Click on this box, then add a series. Then you can do it. I don't know why it just doesn't tell you to do that automatically. My apologies. Reference is not valid. Reference must be. I think I had this error before, and I don't remember why. We'll see. I'll cut this out if it's some weird error that I'm getting. Hold on. We'll try this though. That's fine. Okay. So now what? I'm going to make sure you know to get your, hold on, let me move this out of the way, I can't see. Oh yeah, so once you click on these data points, right click here, then add a trend line, and you will, it'll automatically plot that trend line, and you can display the equation and display the R² value. Okay, so now what I'm going to do, if I just plot everything here, it'll give away the answer to some of the results questions. So I'm going to mix up the graphs. I will just do what I did for the remaining two graphs. You're going to be plotting the natural log of the absorbances with respect to time and 1 over the absorbances with respect to time. And you will just do that in order for 2 and 3. I'm going to mix mine up so that it's not immediately obvious what the answer to some of the results are going to be. And I'll make a note of that for people skipping ahead. But okay, I'll be right back. Okay, so I did some things. Just to recap, do not just take the answers I give to be correct, because I rearranged these charts. So they may or may not be correct. And if you get something different, it might be the right answer. So use what you get from this. But you can see I made some nice graphs. I labeled what they are in quotations. Again, I'm not repeating it again, but you get the idea. Just I rearranged them. Now what are we going to do? Now we want to see which of these graphs is most linear. And how, obviously we can tell that some are more linear than others. This one, you can see it definitely has a distinct curve in it. So you know that's probably not going to be the most linear. This one also has a bit of a curve to it. But if we want to quantify that, we can do that based on this R² value. When R² is closer to 1, it means that the equation for the line that we have given ourselves, that equation is more accurate to the data that we initially put into it. So this one we can see has the highest R² value. It's at 0.99. And you can also see a lot of the data points that we gave it also are on the line of the trend line. So that's how you can interpret the R². If it's a higher value, it means it fits our data better, that the line fits our data better. So over here, I'm going to do the highest R² value being graph 1. And the R² value here is 0.997. And the slope of this line is negative 0.0875. So we have all that information. Some of those things will be important later, but I'll get into that later. How do we determine its reaction order from this? Well, let me pull up something else and we'll go into that more. So as you can see in our lab handout, I want you to look at these graphs here. When we plot the concentration versus time, if this graph is linear, we can determine that the concentration for crystal violet would be 0. It would be 0 order. If the graph of the natural log of the concentration versus time is linear, then the crystal violet will be first order. And lastly, the only thing left, if 1 over the concentration with respect to time is linear, then it will be second order. So that's just how you can kind of tell. Just take that as a kind of a given. And if you're asked to justify how you know the order of crystal violet, just refer to which graph is most linear and what the units, not the units, sure, what the units for the particular plot tell you about which order it is. Or there's a word that it's not units, but what is on the y-axis. You can refer to the handout and just explain it that way. So I'm going to go back to the Excel sheet and we'll continue. So just to repeat one more time what I said, if this graph is the most linear, then crystal violet will be 0 order. If this graph is most linear, then crystal violet will be 1st order. And if this graph is most linear, then crystal violet will be 2nd order. And as we said, this one is the most linear. So because of that, the reaction order is 0 for crystal violet in this given data set. Now I'm going to plot these 3 graphs using this set of data from part 2 the same way. Do it on your own. We'll meet up after. I am rearranging that data set as well in the exact same way I rearranged this one. So don't get confused if your data looks different, but we will meet back here after you've done that. Okay, this is the last time I'm going to repeat it, but remember, these are mixed up. If yours looks different, that is totally fine. I mixed these up to not give away the answer. That being said, I mixed them up in the same way. You can see these curves look fairly similar. Okay, once again, we're going to be looking at our R² value to determine which is the most linear set of data that we have. As you can see, once again, my first graph is the most linear. Oh, another thing, you need to have axis labels with units if appropriate, and you need to have good titles. I kind of just quickly titled these so that you could get an idea of what each thing is, but put a bit more detail into it. I'm giving you this template so make your stuff look nice. Okay, so our highest R² value is graph 4, and its R² value is 0.9971. Its slope is negative 0.0552. And if you don't remember, slope is just given by the value in front of the x here in this equation for y. Okay, and its reaction order, as we said, if the absorbance versus time graph is the most linear, it will be 0 order. So in my example, okay, maybe I will repeat it one more time. In my example, which it's mixed around, crystal violet is 0 order. Okay. So from there, we have most of the things we need, but you'll notice that we still don't have the order determined for our NaOH. And if you don't remember what we're doing, we're trying to solve the rate law for this given reaction. That is the thing that looks like rate is equal to some constant K times crystal violet to some power times OH to some power. We've solved for the power, the order of crystal violet. Now we're solving for OH. Now this is where we are actually going to use a formula. If you want to know the why of this, feel free to come talk to me. But for time's sake, I'm just going to give you the formula and then you can use it. They don't really give you too much information about it in the lab handout either. Actually, let's go look at that. We'll go look at that together. Yeah, there is some important stuff I want to go over here. So again, just take one of these equations. This is the rate law we're trying to solve for. We solved for x, now we need to solve for y. And we have 2 sets of data. That's why we have experiment 1 and experiment 2. And there's 2 equations for those, because our rate will be different when we vary the concentration. And obviously, between part 1 and 2, we kept the concentration of crystal violet the same. And our K value isn't going to change because those typically only change when you change the temperature, which we did not do. So your K will be the same, your concentration of crystal violet is the same, therefore those cancel. And that leaves you with this expression here. The rate for experiment 1 over the rate for experiment 2 is equal to the concentration of OH in experiment 1 to some power y over the concentration of OH in experiment 2 to some power y. And we need to solve for y. And in this, where's the equation that they give you? Oh, they don't give you an equation, but they tell you, hold on, they say somewhere in the calculations here. Based on the straightest line slopes and the initial hydroxide ion concentrations, calculate the reaction order with respect to hydroxide ion using equation 3b. So they also say, because the initial dye concentration is the same for both trials, you can substitute the slopes for the rates and the initial hydroxide ion concentrations. Let's see. Remember to account for the dilution when creating the reaction, meaning that the initial hydroxide concentration is cut in half. Round the order to the nearest integer as well. So that's important. Pause for a second, just pause this video, read over that, try and think about what it means, and we'll talk about it in a second. Okay, so again, we're not going to go into a lot of the reasoning here. If you want to know, come talk to me. But the important takeaways from what this says are that we are going to use our slopes instead of the in place of the rates when solving the equation that we've talked about. This one here. When solving this equation, we're going to be using slopes here instead of rates. And the slopes, yeah. Yeah, so that's the important takeaway. Other than that, the other thing to keep in mind is that, remember, when we make our reaction mixture, we are adding equal parts of the sodium hydroxide as well as the crystal violet. Because of that, you can think of our concentration as having doubled. And because of that, wait, not our concentration, our volume has doubled. And because of that, it's the same thing as having our concentration. If you need to think about it in your head, molarity is moles per liter. If you double the amount of liters, or yeah, if you double the amount of your volume, it's going to have your concentration. So we're just going to use that for this. If you want a super precise version of that, you know exactly how to go from your original molarity to a diluted molarity. And if you want to know, or if you want to do that, feel free to solve it. You can adjust the spreadsheet, but we're just going to have our concentration. Okay, I'm going to pause and go back to Excel. Hold on. Okay, so now let's just write out our formula so we have it here. What that formula said was that rate 1 divided by rate 2 is going to be equal to we're just going to do it, don't worry about it. Okay, our concentration of hydroxide 1 divided by the concentration of hydroxide in our second experiment. And all of this, that's why I have the big parentheses, will be squared. We can rewrite this if we want to solve for the y. Oh, not squared. Why did I say that? To the y. I don't know why I said squared. My bad. So if we want to solve for this y, you might remember what we do is we take the not the natural log, the logarithm of both sides. And when we do that, this can be rewritten just I'm just going to write it over here. Y will be equal to the log of rate 1 divided by rate 2 divided by the log of the concentration of OH in our first experiment divided by the concentration of OH in our second experiment. And if you don't remember why we do this, let's go through it. So obviously, well, okay, we'll start with what happens. So we're going to take the logarithm of both sides. When we do that, a property of logarithms is that we can take anything that's in the exponent of a logarithm and we can just move it in front of the logarithm. So this, if we took the logarithm of it, would be the same as saying y times the logarithm of OH concentration 1 divided by OH concentration 2. That would be the same. I'm not going to write out that middle step. Feel free to prove that to yourself however you want, but just know that this is the formula we're going to be using. And this is how we're going to actually input it. You can leave it like that, or you can, however you need to justify this. Just know how to do it. Okay, now we're going to solve for it. So we're going to do equal to, and now there's a lot of moving parts, so make sure you're inputting everything correctly. So hold on, I am going to do log, and then let's see. So we need to do rate 1 divided by rate 2. And if you remember from the handout, we are going to be using slopes instead of rates. So slope 1, hold on. I had to sneeze, but it didn't happen. Anyway, okay, divided by slope 2. Okay, and all of this will be divided by the logarithm of the concentration of OH. But remember, this is the important thing. You have to have your concentration. And again, we can solve it exactly, but I'm going to give you guys a little bit of a break from that, and we're just going to do this divided by 2. Oh, and we need a bunch of parentheses in here to make sure that it's calculating it correctly. So remember, from we need a parentheses around the B3 divided by 2. So make sure it does that first before doing anything with the logarithm. Then we need another divided by, and we can do the other half of this logarithm, the concentration of OH2. And we need another parentheses opened because we have to make sure it does that first. And we're going to do this divided by 2. Because, again, we have to have the concentration because we doubled the volume, the total volume of our reaction mixture when we mixed the two things. Okay, so then I think I need one more parentheses to just wrap up that formula, and then I should be able to just press enter. There we go. And obviously, this isn't a perfect, it isn't a perfect whole number, but if we rounded it, it would round up to 1. And therefore, the reaction order with respect to OH will now be 1. And you can format that on yours, make it look nice, or do whatever. It doesn't really matter as long as you have everything there. Okay, so that is all the calculations we have to do. Not too bad. I know there's a bit of kind of some tricky theory stuff. Again, if you want to know more about it, just come talk to me. I would be happy to talk about it. But I do have this other segment with some questions I need you guys to answer in order to get full points. So just go ahead and write these out. You can print out both sheets and then just fill it in, you know. Let's see if there's anything challenging in here. You need to identify whether or not you had the same order determined for parts 1 and 2 for your crystal violet. If not, then explain what some causes might be if you had any errors or anything like that. And also, I need you to tell me how you know the order for crystal violet, just repeating kind of what we said, what we gathered from the handout, as well as what we gathered from our graphs. So just write out how you know the order for your crystal violet. Be specific in order to get points. Determine the overall reaction order. Remember, for the overall reaction order, you add up the individual orders for the reactants, and then give me your final calculated. Did I spell that wrong? I totally spelled that wrong, didn't I? Does it not fix spelling? Calculated. Oh well, okay. Okay, final calculated rate law. Just write that out. Remember, that's of the form, well, you can find it in your handout, but write it in the form that they give you in the handout. Okay, there is one question I didn't completely type out. Just refer to question 6 in the lab handout and just answer that in this box here. And then identify some error sources and ways to improve your results. I think there are some points back for if you give good justifications for your errors, if you kind of messed up with, or if your data is weird, I should say, for your crystal violet calculations, then you can get some points back. So yeah, good luck with this. This isn't too bad. I know there's some weird theory, but calculations wise, shouldn't hopefully take too long. Remember, if your stuff doesn't look exactly the same, That's okay. I mixed some stuff up, and good luck. I will see you guys tomorrow for your quiz, and then on Wednesday where you will be turning this in. And good luck.